Okay, everybody, example number 2, find the value of the variable. So the first thing I'm going to look at is I'm going to look at these two secant lines, which are intersecting on the inside of my circle. Now, the arcs that I've mainly been given is you're mainly been given this y up here and this 95 down here. And the theorem that we have says that if I take that y degrees and I add it to that 95 degrees, it's going to get, well, then you have to cut it in half. So you take the y, you add it to the 95, you cut it in half, it's going to give you the measure of that angle right there. Well, the variable is y, and that's what I'm really trying to find. So I'm wondering if there's a way that I can find that question mark so that I don't have a couple variables running around here. So what I'm really looking at now is I'm looking at this straight angle. If you're looking at the straight angle, you should be thinking, okay, well, two angles on a line add up to 180 degrees. So I'm going to take 180. I'm going to subtract 102. So 180 minus 102 is 78 degrees. So I know that the angle measure right in here is 78. Then I can take my theorem. If I have two secants intersecting on the inside of the circle, you take the two intercepted arcs. So we're going to take the 95. We're going to add it to the other one, which is y degrees. And then you're going to cut that in half. And then that equals the angle created inside the circle, which we just found was 78 degrees. Now, solving this, first thing I'm going to do, I'm going to multiply both sides by 2. So 78 times 2 is 156. So now we've got 95 plus y equals 156. Then I'm going to subtract my 95, which is going to give me y equals 156 minus 95, which is 61. So we know that that arc is 61 degrees. Letter C. Find the value of the variable. I'm looking at A. So this time we have two secant lines, but they don't intersect inside the circle. They intersect outside the circle. So now that they're intersecting outside the circle, there's my first intercepted arc. There's my second intercepted arc. And instead of adding together and dividing by 2, because they intercept outside the circle, we have to subtract. So you always take the larger arc. So I'm going to take A minus the smaller arc, and then we're going to cut that in half, and that's going to equal the angle that is formed in between the two secant lines. And if you're confused on terminology there, that's the secant line, that's the secant line. Excuse me. Remember, a secant line intersects the circle twice. So now we're going to solve this one. Again, I'm going to multiply by 2. So A minus 44 equals 60. Then I'm going to add 44. So 60 plus 44 is 104. So we know the measure of that arc is 104 degrees. Letter B. Okay, so this one, we've got our two tangent lines. And then we've got our two radii, which means we know if we've got two tangent lines and two radii, we know that's a 90 degrees and we know that's a 90 degrees. So opposite angles add up to 180 degrees, which means these opposite angles must add to 180 degrees. Well, the other way to figure that out is you're going to take 180 degrees minus 120 degrees, which is going to leave you with 60 degrees. So I know x must be 60 degrees. Okay, last one of these. Kind of the same idea. We've got opposite angles in a quadrilateral. Now, what I want you to think about here is if you're taking a look at this guy, is that a central angle? In the last picture, and I'm actually going to go back here, do you guys notice that 120 degrees comes out of the center of the circle? So we could use that theorem where they have to add to 180, and we can do 180 minus 120, and it's just 60 degrees. But if you take a look at this one, x degrees is not coming out of the center, it's coming out of a vertex, which means I don't really know if they are 180 because that theorem doesn't work unless the entire quadrilateral is inside the circle. And in this case, point S is outside the circle. So we're going to have to think of something else here. Now, the first thing I'm going to think about is I'm going to look at that angle X, and I'm going to look at its intercepted arc. Do we remember that if we have an inscribed angle and an intercepted arc, that it's like half of it? So if the angle is X and that's half of it, then that means that this arc must be 2x. Well, then I'm going to take my arc and I'm going to connect it to my center. So if we have an inscribed one, the blue angle, it's half of the arc. But if we have the green angle, which is a central angle, it is equal to the arc. Okay, so keep that in mind. And then once I know that the central angle is 2x, now I'm back to the same example that we did, and I'm going to flip back again on this guy, where you can do 180 degrees minus that central angle. So now I'm going to do 180 degrees minus my central angle equals the angle formed between the two tangent lines. And then we just have to solve this for x. So first thing I'm going to do is I'm going to subtract 180. So negative 2x equals negative 130. Then I'm going to divide by negative 2. So x equals negative 130 divided by negative 2, which is 65. So x must be 65 degrees.